Find the volume of the solid obtained by rotating the region bounded by y squared is 4x and y is x. And this is going to be rotated about the line x equals 4. First step in the process is to draw the graph. Now we have y squared equals 4x, and that's just going to be a parabola that's on its side. Now you could also think about it as this is easy enough where we can take this and solve it for y by taking the square root of both sides. When we do that, don't forget that we have plus or minus, and then square root of 4, we can break this into two square roots. The square root of 4 is 2, so it'll come out as 2 square roots of x, plus or minus. The plus would be the upper part of the parabola, and the minus would be the lower part of the parabola. Remember, it's a parabola on its side because the y is squared. The other one is just y equals x, that's just the line. What we need to find out, of course, is where they intersect at. Well, if y squared is equal to 4x and y is x, you can replace this x with the y and say y squared is 4y. I want you to avoid dividing by y, because then you end up losing one of the solutions. So you want to set it equal to 0. Subtract the 4y over, and then factor out the y. You have two terms multiplied to give you 0. Y times y minus 4. Either y is 0 or y is 4. So those are the two places where they intersect. Now remember, x is equal to y, so that's also the x is 0 and x is 4. So they intersect at these 2 points. 0, 0, the origin, and 4, 4. Okay, so the drawing is going to be, here's the x and y axis. We have a parabola that's on its side with this vertex at the origin. And then we have the line y equals x. And it's the region bounded by these two. So we're talking about this region in here. This gets rotated about the line x equals 4. Now remember, 4 is where they intersect at. So we're going to rotate around the line x equals 4, and we want to find the volume of that shape. We need to figure out which method to use. The second step is to figure out which method to use. To do this, we have two graphs. These are computer generated graphs, and we want to be able to figure out, should we do it with shell or with disk / washer. When you draw a rectangle that's parallel to the axis of rotation, that's going to be shell. When you draw a rectangle that is perpendicular to the axis of rotation, it's either going to be disk or washer based on the fact of whether or not there is a gap between your region and your axis here. Your region has a gap between it and your axis, so it's going to be washer. This rectangle for shell is a vertical rectangle that's moved to the right, so it's going to be an X. For washer, this is a horizontal rectangle that's moved upward, so it's going to be in Y. Let's take a look at shell, and then we'll also set up washer, and we'll pick one to do. The formula for the volume with shell is to integrate 2 pi times the integral from a to b, the radius times the height. We need the radius and we need the height. Now, because this is in x, we need to take our equation and solve it for y. So we have a formula that's in x. And so the square root from both sides that we saw before, y is equal to 2 root x. So what is the radius and what's the height? Well, the radius will connect your rectangle to the axis. And you know what that is? We have this distance, that's the subtraction of one distance from another. We have the distance that takes us all the way to the line, that's 4, and then we have the distance that takes us up to the rectangle, and that's the distance off the y-axis. That's called x. And since we're in x, we leave it as an x. So this radius then would be 4 minus x. Okay. All right, great. Well, what about the height? So the height is how tall the rectangle is. And that's going to be the difference between the two functions. The square root function minus the line. And you already go. We can go ahead and plug in the limits of integration. This starts when x is 0. It ends when x is 4. So that's A and B, 0 and 4. So we definitely could do this. Multiply the radius times the height and integrate that. Let's look at washer, and we'll pick one of the methods to do. With washer, the formula is the outer radius squared minus the inner radius squared, and you integrate that. And we know we're in y. Now because we are in y, we can't have this formula like this. We have to solve it for x. So just divide by 4. X is equal to y squared over 4. And we need the outer radius and the inner radius. The outer radius is a line that goes from the axis of rotation through the region to the end of the rectangle. Once again, that's a subtraction of two distances. We have the distance that takes you from the y-axis all the way to the line again. That's 4. And then we have this distance here that takes you off of the y-axis. And remember, that's x. Now we can't have this as x though. Remember, our integral is in terms of y. So what do? We replace with the formula for x. So instead of 4 minus x, what we're going to get is 4 minus y squared over 4. Now we need the inner radius. The inner radius is a line that's from the axis of rotation to the region. And that's also going to be subtraction of one distance from another. We have that same distance 4 and this same distance x that we need to subtract from it. But now it's not the x for the parabola, it's the x for the line. So we replace that x with y. But don't forget though, we have to square these guys and then subtract and then integrate. How about the limits of integration? They're going to be the same. Y starts from a low point of 0 and goes to a high point of 4. So we have these two methods. Let's choose to do washer method. Not that shell is bad to do, we're just going to pick one, and washer is the one we're going to go with. So now let's perform the calculation. Okay. So from before we have the setup, and we need to square out 4 minus y squared over 4. 4 times 4 is 16. 4 times y squared over 4, the 4's cancel and you get minus y squared. Another one, minus y squared. And then these two guys times each other gives you y to the 4th over 16. And that actually should say plus, sorry about that. Okay. What about here? Well, squaring out the other guy is just going to be, 16 minus 8y, because the 2 of the negative 4y's, and then plus y squared. And so now we've squared them out, and now we need to look at how we can put them together. I mean, hey, there's a 16 and there's a subtract 16. We have a minus 2y squared, and from that we subtract y squared. So we have minus 3y squared. There's the y to the 4th over 16, and then there is the positive 8y. So it's not a bad integral at all. We're integrating from 0 to 4. What we need is the antiderivative. How do we find that antiderivative? We take each term separately. If you have minus 3 and get y cubed over 3, the power rule in reverse here, we're going to get just minus y cubed. If we have y to the 4th over 16, we add 1 to it, and then divide by that same thing. So that's y to the 5th over 16 times 5. We're going to find out, without a calculator, sometimes it's best to leave things like this. I mean, yes, it is, you know, we can multiply it out, definitely. We can get 80, but it's better for us to leave it as 16 times 5, because we're going to get powers of 4 we can easily cancel. And the last one is 4y squared, so you get y cubed over 3, y cubed, it's 8y. And so you're going to get 8y squared over 2. That's 4y squared. Okay, great. So we have our antiderivative. We're ready to plug a 4 in, replace all the y's with 4, replace all the y's with 0, and subtract. Conveniently, 0 gives us 0. And watch what happens with the 4's. We have this minus 4 cubed. The 4 gets cubed first, and then there's a negative. But then on the last term, we have 4 times 4 squared. And so that's a negative 64 and a positive 64. Those two cancel each other out. Now we need just this. You know, you don't have a calculator, so please don't try to multiply out 4 to the 5th. What you should do is write down 4 5 times. Write 5 copies of 4 down, because you have the 16 in the denominator to cancel. And now you just have 4 cubed over 5. The final answer to the question, 64 pi over 5. Okay? Alright, great.